Imagine this, a world where a really devastating injury isn't, life sentence anymore. Think about a firefighter. His whole career just shattered by third-degree burns, told his skin would, well, never truly heal. Or a young mother, used to be an athlete, right? Suddenly you can't even lift her toddler because of a torn rotator cuff. She's facing a future with really limited movement. And then there's a man, maybe late 50s, his heart scarred, failing after an attack, given a pretty grim prognosis. For way too long, the message for so many people has just been, look, there's nothing more we can do. Your body is simply broken. But what if broken isn't really the end? What if right now, today, Friday, July 4th, 2025, the very cells inside you hold the blueprint for rebuilding, for regenerating, for maybe a second chance? We're about to take a real deep dive into a revolution that's redefining what medicine can actually achieve.
It's a huge shift, isn't it? I mean, for decades, our focus has often been just managing conditions, kind of patching things up as better we could. But what we're seeing now, it offers a completely new way of thinking. It brings real hope where, honestly, there were mostly limits before. We're sort of stepping into an era where possibilities that really felt like science fiction are becoming, well, a tangible reality.
Okay, right. Let's unpack this a bit. We should look at how this new reality is impacting real people, people with incredibly tough conditions. So consider Liam, a firefighter, right? A hero. He got 40% third-degree burns during a rescue. Now, traditional treatments, even with lots of skin grafts, they left him facing lifelong pain, pretty severe scarring, and really limited mobility. His career is active life, basically over. Then you've got Sarah, a young mom, used to be very athletic, a simple fall, but it led to a torn rotator cuff so bad it was agony for her to lift her own child. Surgeons were kind of hinting at a future where, simple things like picking up her toddler might just be permanently off the table. And lastly, Mark, 58 years old, after a really bad heart attack, big parts of his heart muscle turned into scar tissue. That led to debilitating heart failure. He was weak, constantly exhausted, facing increasingly grim sort of end-stage options. Things like the daunting idea of a heart transplant. For Liam, Sarah, and Mark, their lives were really defined by what their bodies couldn't do anymore.
And that's exactly where the profound impact hits home. Liam, Sarah, Mark. Their stories are deeply personal, sure, but they reflect the reality for millions of people around the world. We're talking about serious injuries, chronic diseases that just fundamentally change what normal means. Not just for them, but for their families, their communities. It's about lost independence, a compromised quality of life, this pervasive feeling of limitation. That's why this medical revolution isn't just like scientifically interesting, it's absolutely vital. It promises this fundamental shift from just managing symptoms to potentially reversing damage right at the cellular level, restoring function that everyone thought was lost forever.
Okay, so how do we get from that really grim outlook to these incredible new possibilities? What's the science behind these biology's master builders, as some call them, stem cells? For our listeners, many of whom follow this field closely, can you give us a quick refresher? What exactly are these blank slate cells? How do they work? Are they truly blank slates?
Yeah, that's a great question, and it really gets to the heart of their power. As many listeners probably know, stem cells have two truly remarkable properties. First, they can replicate endlessly, basically make more of themselves without limit, which is crucial for building and repairing tissues. Second, and this is where that blank slate idea comes in, they can differentiate. That means they can transform into any type of specialized cell, given the right signals, of course. Think of them like the body's original architects during embryonic development, laying down all the different tissues and organs. And no, they aren't entirely blank slates. Some adult stem cells, for example, have a more limited range than embryonic ones, but their job doesn't stop at birth. They keep acting as these lifelong repair crews, regenerating and mending tissues in places like our bone marrow, our fat, maybe even our brains. The big breakthrough wasn't just finding these cells, but figuring out how to control them, how to tell them what to become. For a while now, scientists have been able to take a patient's own adult stem cells, grow more of them in the lab, and then use them in a targeted way. This really helps minimize the risk of rejection, which is a huge issue with other transplants.
And it's not just about using the cells that are already there, is it? I mean, one of the most groundbreaking things, truly a game changer, won Nobel Prize, is something called induced pluripotent stem cells, iPSCs. This tech literally lets scientists reprogram adult cells like, say, a simple skin cell from your arm and turn it back into that versatile stem cell state, almost like winding back its biological clock. It's just an incredible leap, offering a basically limitless and perfectly personalized supply of stem cells for treatment.
Precisely. And that's why regenerative medicine isn't just some future idea. It's a rapidly advancing field right now as we speak. It means we're moving beyond just managing symptoms or, patching things up. We're harnessing these cellular advances to heal damage right at its fundamental root, at the cellular level. It's like an inside-out repair job, if you will, using the body's own amazing capacity.
So how did this science actually become a lifeline for Liam, Sarah, and Mark? Let's walk through their journeys, what actually happened. For Liam, the firefighter with those terrible burns, he got into a cutting-edge trial. Doctors used his own stem cells, grown in the lab. They didn't just use them for grafts in the traditional way. They used them to grow new, healthy skin in the worst-hit areas. The goal was to go way beyond standard grafts, to really reduce inflammation and scarring at a cellular level, to push for truly functional recovery, minimize disfigurement. And Sarah, the young mother, she made a pretty bold choice, bypassing immediate surgery for her rotator cuff. She opted for injections of mesenchymal stem cells directly into her shoulder. Now, for listeners, mesenchymal stem cells are a specific type found often in bone marrow or fat.
They're known for being very potent.
Right. They have powerful anti-inflammatory and regenerative properties. The hope was these cells could naturally heal the tear, letting her avoid surgery altogether. And Mark, with his failing heart, his treatment involved injecting bone marrow stem cells right into the scarred tissue of his heart muscle. The aim was sort of twofold: reduce the inflammation that was dragging him down, and also promote actual muscle regeneration, trying to restore vital function to that critical organ.
Yeah, and what's really important to remember here is the anxious wait each of them faced. I mean, the science was incredibly promising, the potential was clear, but the outcomes were still unfolding in real time. Their hope was really tied to these cellular transformations, this deep belief that their own bodies, maybe with the right scientific nudge, could heal themselves from the inside out. It's a powerful thing, human resilience meeting medical innovation. And, while these stories are incredibly optimistic, it's also crucial we remember that outcomes can vary. This is still very much an active area of research and refinement.
And the results that followed. For these individuals, they were, well, pretty stunning. Transformative. For Liam, the change was incredible. The areas treated with his stem cells healed remarkably quickly. The skin was flexible, with minimal scarring, something really thought impossible for burns that severe. Within about a year, he'd regained mobility he thought was gone forever. He was living almost pain-free. Liam got his life back. His firefighting career was over, yeah, but he found a new sense of purpose and that physical freedom again. Sarah's recovery. Equally compelling. Her shoulder pain started fading just months after those stem cell injections. Follow-up MRIs actually showed clear evidence that the tendon was healing. Her body was literally regenerating itself from within. This meant she could lift her child without pain, effortlessly. That simple act that used to bring tears to her eyes. And she completely avoided invasive surgery. And Mark. His improvement genuinely gave him a second chance. His breathing got easier. That crushing exhaustion that had defined his life for years, it finally lifted. Scans showed a significant reduction in the heart scar tissue, and more importantly, noticeably better heart function. He could take longer walks, really engage with his family again, experience life, all because of regeneration happening inside his own body.
What's truly fascinating here is just how powerfully these specific cases underscore the potential of stem cells. These aren't just isolated stories. They're tangible proof of concepts that were maybe just a decade ago purely theoretical. Now they're real. They show the body's incredible capacity for repair when it's given the right tools, or in this case, the right master builders. And while every patient's journey is unique, these outcomes give us amazing insights into where this field is heading.
So Liam, Sarah, and Mark's stories happening right now, they aren't science fiction. They are absolutely harbingers of medicine's future. They give us a very clear glimpse of what's becoming possible.
Exactly. And if we connect this to the bigger picture, it gets even clearer. Stem cell therapy isn't just some futuristic dream. It's already established for certain things. Think about blood cancers like leukemia. Bone marrow transplants, which have been used for a long time, are essentially a form of stem cell therapy.
Right, that's true.
But the real excitement now is in the rapidly expanding trials. We're seeing intense research, really promising results for conditions like Parkinson's disease, stroke recovery, severe spinal cord injuries. Type 1 diabetes are working on growing new insulin-producing cells from stem cells. Even things like liver regeneration. The scope is enormous.
Wow.
Now, of course, challenges remain. As we touched on, outcomes can still vary quite a bit from person to person. Many therapies are still in trial phases. We need ongoing, rigorous study to really understand long-term effects and figure out the best ways to deliver these treatments. But the progress is accelerating almost daily. The scientific community is constantly refining these techniques, pushing boundaries we didn't think were possible even a few years ago.
What we're really witnessing here feels like a profound philosophical shift in medicine, doesn't it?
Hmm.
We seem to be moving beyond just managing chronic conditions, which often means a lifetime of pills or therapies that just limit the damage towards actively healing them. It's about unlocking the body's own innate power to rebuild itself from the inside out, making our own biology the ultimate medicine.
Yeah, and this raises a really important question, doesn't it? How does this profound ability to potentially heal from within fundamentally change our understanding of health, of disease, of recovery itself? It challenges these long-held assumptions about what's truly possible for the human body. It's a whole new perspective.
And that's a powerful thought to leave you with, isn't it? That incredible, maybe still untapped potential residing within your own body for healing and regeneration. For more incredible insights like this deep dive, make sure you visit Mind Expansion Daily. We're constantly exploring the frontiers of knowledge, just like we did today. And while you're there, please make sure to like and subscribe to Mind Expansion Daily to get even more great information like this. Thanks so much for joining us for this deep dive.